Welcome back to The Explainer. So let's just get right into it. Have you been watching this whole AI boom from the sidelines, kind of wondering how on earth you're supposed to catch up without a PhD or years of research experience? Well, you are absolutely not alone. Today, we're demystifying the transition into AI engineering with a concrete, step-by-step 6-month roadmap. We're going to map out exactly how you can learn AI from zero. Because listen to this. The Tech Society recently pointed out a timeline that is frankly pretty staggering. They suggest that AI might handle most end-to-end software engineering tasks by summer or fall 2026. I mean, wow, right? This brilliantly illustrates a real existential shift in the industry. Traditional coding is rapidly changing. But here's the secret. The job isn't going away, it's just transforming. Right, so the crucial thing to understand here is this massive transition. We're moving away from the traditional engineer, the one who gets bogged down in syntax and manual coding, to this future AI engineer. Think of this new role almost like being a conductor of an orchestra. You aren't writing every single function from scratch anymore. Instead, you're orchestrating these incredibly powerful existing AI systems and APIs, using system-level thinking to architect solutions to actual business problems.
Okay, so here's our syllabus for this explainer. We're going to break this intimidating journey down into manageable milestones. First up, month 0, the AI landscape. Then, months 1 and 2, prompting and systems. Month 3, mastering RAG. Month 4, autonomous AI agents. And finally, months 5 and 6, deployment and specialization.
So giving you a quick bird's-eye view of your whole timeline. I know, it might look like a lot to absorb at first glance, but when we map it out chronologically over 6 months, you can really see how each concept just naturally builds right on top of the last one. And remember, you don't need to be an expert coder to begin this journey. You really just need to be comfortable enough with basic Python to call APIs and process data.
All right, let's kick things off with month 0, the AI landscape.
Now, I see people constantly wanting to rush straight into coding during this initial phase. And honestly, a few months later, they end up making terrible architecture decisions because they completely miss the foundation. In month 0, your goal isn't to build a product just yet. It's to play, test, and really grasp proprietary APIs like OpenAI or Anthropic and compare them to open source models. And at the very core of all that foundation is the large language model, or LLM. If we strip away all the sci-fi marketing hype, what does an LLM actually do? It predicts the next word. Literally, that's it. Computers don't actually understand English. They understand numbers. So your text is converted into numerical tokens, and the model just calculates the most mathematically likely next token based on massive statistical patterns. It is basically an extremely sophisticated autocomplete.
To kind of visualize how that prediction actually happens, take a look at these notes. See how they're arranged across the input layer, the hidden layers, and then the output layer? By the way, when people throw around the term deep learning, all they're strictly referring to are models that have more than one of these hidden layers. As data passes through this web, the nodes combine features from the previous layer to recognize increasingly complex patterns. It's like a giant puzzle assembling itself.
And beneath all of that magic, it really is just math. Take the sigmoid function, for example. It's used to shape or squash a node's output into a value strictly between 0 and 1. As the network learns, it's kind of like a blindfolded runner navigating a track. It makes a guess, calculates its error against the actual ground truth, and then uses calculus, specifically a concept called gradient descent, to systematically adjust its internal weights so it can make much better guesses next time.
Moving right along to months 1 and 2, prompting and systems.
Okay, I need to emphasize this right up front. Prompting is rigorous engineering. It is not just some soft skill. In month 1, you've got to get your hands on the keyboard and build exactly these 3 core apps: a domain-specific assistant, a structured data extractor, and a multi-turn conversational app. Building these specific projects is going to force you to grapple with the frustrating realities of token limits and context windows. But more importantly, it forces you to develop a systematic workflow for iterating. Because when your AI fails, and it will fail, you don't just randomly tweak the prompt and pray. You form a hypothesis, you make a targeted change, and you test it again.
Then, as you transition into month 2, your whole mindset has to shift. You've got to move away from just writing individual prompts and start building robust, multi-component systems. Let me tell you, a prompt that works 90% of the time is essentially useless in the real world. It's that 10% edge case failure rate that is going to drive your actual users completely crazy. So you have to start architecting systems where multiple different components are working together to validate and verify the AI's outputs.
Next up is month 3, mastering RAG.
Now, if you want to build things that actual companies will actually pay for, this is the technology that bridges the gap. RAG, which stands for Retrieval Augmented Generation. Essentially, this allows an AI model to bypass its own training limitations. So instead of hallucinating some answer based on whatever it vaguely remembers from reading the public internet, RAG allows your app to search through specific private databases, like your company's highly confidential internal documents, retrieve the exact facts, and then generate an answer strictly based on that retrieved context. It's a total game changer.
And the RAG pipeline follows these exact 5 steps every single time: chunking, embedding, storage, retrieval, and generation. Your strategic choices here matter immensely. For instance, how you decide to chunk or chop up your documents in step 1 dramatically affects the quality of what you can retrieve later on. But you want to know the real secret to standing out here? Evaluation. Seriously, most developers have absolutely no idea if their RAG system actually works properly. If you can create rigorous test sets to literally measure your retrieval accuracy, you are already miles ahead of the pack.
Which brings us to month 4, autonomous AI agents.
This is where AI engineering crosses the threshold into creating systems that feel, well, genuinely intelligent. An agent actually takes multiple independent steps to accomplish a goal, running through a core loop: observe state, decide action, execute, and repeat until done. To build this successfully, you've really got to understand planning frameworks that let the agent break down super complex tasks. You have to implement memory systems, and most importantly, you need incredibly robust error handling. Look, APIs are going to time out, and agents are definitely going to go down the wrong path. Your system absolutely must know how to recover gracefully.
All right, the home stretch, months 5 and 6, deployment and specialization. At this stage, we kind of hit a harsh reality. An AI project that runs exclusively on your local laptop creates absolutely zero business value. None. You have got to get your work out into the real world. For your deployment stack, you'll want to learn Fast API for building your APIs, Docker to containerize your app so it runs reliably literally anywhere, simple cloud platforms like Railway or Render, and observability tools like Langsmith. That last one is crucial so you can actually monitor what on earth your LLM is doing out there in production.
And by month 6, it's time to stop being a generalist. You really need to pick a lane. Are you going to focus on crafting incredible user-facing apps? Or maybe you're drawn to the complex backend infrastructure and MLOps. Are you fascinated by agents and autonomous systems? Or do you want to dive deep into open-source fine-tuning? Whatever it is, pick one of these paths. Spend this final month building a highly polished, very public capstone project that proves to the world you can execute.
Actually, if you're looking for an incredibly exciting specialization to consider, let me point you toward multimodal AI. Unlike early AI that only handled text, multimodal models can seamlessly process diverse sensory inputs all at the exact same time. Just imagine an application that can visually see a complex chart, listen to an audio explanation of it, and read a text prompt to generate one cohesive answer. Processing across all these different sensory dimensions is without a doubt the most thrilling, cutting-edge frontier of the field right now.
Which brings us to our final thought for this explainer. The playbook for AI engineering is genuinely still being written as we speak. It is completely normal to feel intimidated by all this, but the honest truth is, the barrier to entry right now is actually lower than in traditional software engineering. You just need to be willing to build things that work. This field fiercely rewards builders over studiers. So, armed with this 6-month roadmap, the only question left for you is, what will you build by 2027?